Okay, so we have done making the unit circle before, but we did it with angles. Now, angles are something that students intuitively come in with, and they're pretty good with, 30s, 45s, 60s, 90s. But uh, there's that learning curve that comes with working with radians. So I'm going to teach you how to make your unit circle. So obviously just giving it to you isn't enough. We have to learn how to learn it. And I'm going to give you some ways to be able to draw it very quickly when you show up on my test or on the diploma. You can just get this thing down. Now, the first thing we're going to deal with is all the, I guess, we'll do the 45s first, okay? So the best way to draw your 45s is just draw a line, you know, kind of your best that you can, halfway there and halfway here. Okay, again, if they're not perfect, don't worry about it. Just remember, I'm a trained professional. Okay, now let's walk around the circle doing pi over 4, because every one of those pieces are pi over 4s. So this is pi over 4. This would be 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. So I need you to get you thinking that anything over 4 is talking about 45s, okay? There's a 4 and 45, so remember, if it's pi over 4, now if it's pi over 2, I can make it into 4s. And then I can count it around. Okay? So just some kind of little notes to have, you know, that what's 30 degrees, what does that equal? Pi over 6, good. You know, 45 degrees is pi over 4. What are some other ones? 90 is pi over 2. 180 is pi. We got 270 is what? Everyone remember? 3 pi over 2. And 360 equals 2 pi. Okay, now, again, we're just going to focus on the 45s, and then we'll talk about the rest later. Now, when you do an entire unit circle, when you look at it at one time, so, like this is the one we did with the last class, okay? It looks extremely complicated. But what you need to do is you need to look at just the 45s by themselves. You just need to look at the 30s by themselves, okay? And when you start seeing it that way, this isn't so bad. But when you look at this in one thing, it looks like this is going to be the worst thing ever, okay? And, you know, if you left this like maybe on the kitchen table last night or tonight, you know, and parents walk by, they're going to be pretty impressed, right? And you think you're like a genius or something. And then you go, you know what, Mom? I got that memorized anyway. You can throw that away. And just walk away. That's all you do. Maybe go like this or something after. Okay. So now we're going to walk around and do just the 45s that are on each side. So this one is root 2 over 2, root 2 over 2. If we reflect that over the y-axis, it should make sense. This is negative root 2 over 2, root 2 over 2. Now we're going to do a reflection on the y-axis to come down. That is negative root 2 over 2, negative root 2 over 2. Then one more time. Root 2 over 2 and negative root 2 over 2. Now, the other thing that, remember, we always had to know, this is cos, this is sine. This is cos, sine, cos, sine, cos, sine. What we are missing are the tans, though. Right? Because we need to know cos, sine, and tan for every one of those. Like 7 pi over 4, we need to know what sine of 7 pi over 4 is, cos of 7 pi over 4, and tan of 7 pi over 4. So let's look at quadrant 1. What do you think root 2 over 2 divided by root 2 over 2 would be? It would just be 1, right? Now on the other side, to see how we would have a, because it's sine over cos, we would have a positive divided by a negative, so that'd be negative 1. This would be 1, and this would be negative 1. Now again, I also want to reinforce that this would be the cast rule. Okay, do you notice that this is very consistent with it? In quadrant 4 or 3, look, tan is the only one that's positive. Both cos and sine are negative. So not only does it make sense that in quadrant 3 both are negative, because we're on a negative x and a negative y. Like, look where it is. It's 0, 0 in the middle. Okay? So really, if you got quadrant 1 done, you should be able to think about 2, 3, and 4 from there. But what I would do is I'd do my unit circle, I'd put my 45s in, then I would do my 30s, I would write them in, and then I would complete quadrant 1. And then it's like, okay, get on to my test. Now, let's finish the 45s. Now, when we start right here, what is this point? Or what's the radius? It's 1. So this must be 1, 0. Okay, what would tan be there? Because it's 0 divided by 1, right? So it'd be 0. So just write your cosine tan on top. Okay, now let's move up to the top here. What is the point up there? 0, 1. What would be tan? Undefined, right? Because if you take 1 divided by 0, this is cos, sine, and tan. Okay, let's go to the other side. What would that be? Negative 1, 0. What would tan be? 0. Okay, very bottom will be 0, negative 1. Good. What would tan be? Undefined. Okay, now let's just get all of our 30s done. Now, if you do have different colored pencils when you go in and bring a ruler, you do get to make your unit circle where it's going to make more sense. So let's just put our 30s in quick. Now, it's not in the middle of those other that red, and it's kind of because 30s. But you know what? If it's in the middle, it's hopefully you want. Yeah, maybe you should just try and change that. Yeah, you only did one wrong, so just erase it. See, the 45's cut nicely in the middle, but 30s, there's got to be 3 of them in each quadrant, so obviously they won't go through the middle, right? Okay, now maybe a little bit higher up the line we'll do our 30s, because I mean, if they're in that mess, I mean, already I think the 45s have been taking a lot of the room. So we start at the first green line. Yeah, I just got a few people that are making lines, so I'll wait for a sec. Okay, so let's start going just around. Now, the first one would be pi over 6. Now make sure we're just staying on the green. The next one is 2 pi over 6. Then 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. And 11 pi over 6. And 12 pi over 6. So make sure you never skip the x or y axis. They are counted as 1. Now, as you can see, a lot of these need to be reduced. Like every one that's on the x and y axis need to be reduced. Now you can look at the first one. If we go around, let's just go around the whole circle. It's 2 pi over 6, which is pi over 3, right? Know that those two are the same. The next one's going to be pi over 2. And 4 pi over 6 is 2 pi over 3. Then that one, 5 pi over 6 can't be done. 6 pi over 6 is going to be pi. 7 pi over 6 doesn't work. 4 pi over 6 can't go down. 8 pi over 6 is 4 pi over 3. 9 pi over 6 is reduced to 3 pi over 2. 10 pi over 6 would be 5 pi over 3. And 12 pi over 6, or 8 pi over 4, will be 2 pi. Okay, now the last thing we're going to do is we're just going to look at quadrant 1 and 2. Do 1 first, and then we want to see how easy 2 and then 3, 4 would be. Now, as I'm going up, pi over 6, do you remember, is root 3 over 2, comma 1/2, right? Does anyone remember what tan was there? You have to take sine divided by cos, and you get root 3 over 3. That's cos, sine, and tan. Okay, the next one, pi over 3, is just the reverse of those two. 1/2, comma, root 3 over 2. But the answer is root 3 for 10. Now, all we want to do is across the y-axis is reflect them all. So this will come over here, this already came here, and this is coming over here. Okay? So if that's coming over there, that's going to be negative 1/2 comma root 3 over 2 and negative root 3 is 10. Because when you reflect it, it is x turns to negative x. And the other one would be negative 3, or root 3 over 2, 1/2, and 10 would be negative root 3 over 3. Now it looks like that complicated mess that I showed you 5 minutes ago. That is your unit circle. Okay? So now you know how it was made. This is the best way to actually construct it. And when you get to a test, it's not going to be fancy. But get all those lines in. Get all your pi over 4, 2 pi over 3, all the way to 8 pi over 4, and then get your pi over 6 all written in. Do your first quadrant, and then go. And you'd be surprised how fast you can do something like this. Okay, rip out a blank sheet that's on the back. You're inside the book, whatever you need to do, right? If you have a formula sheet, you could write this on the back. It's basically a formula, right? Formula sheet you rip out. Why don't you write this on the back? And it is an investment, okay? Because there is long ways to do all these questions. But after a while, the time that you spend doing the questions would surpass learning this. Because as you will see, when we do these questions in the following examples, there's absolutely no work to do if you know your unit circle. Like none. Okay? But I need you to know the work way as well, because I might ask you in a written response. But the nice thing about it is you know your unit circle, so you will be able to verify your answers and know they're right. Okay? So let's go and do some of those. Lesson 4. Okay. Now, we're going to start doing, I guess, the real trig today, where we have to find out what angle would give this answer. Okay? So here's 3 steps that we're going to be able to solve it well. The first thing is always determine the quadrant the angle is in by looking at the sign of the ratio. That's number 1. And I will number the steps as we go through this so you can always look up and say, what's number 1 again? Oh, yeah. Okay, number 2, we will find the reference angle by using second sine, second cos, or second tan. Remember, when finding an angle, you always need to use inverse sine, inverse cos, inverse tan. And always do the absolute value. Don't put in negative. Always the positive. And then the third thing is determine the rotation angles. Okay? Well, let's see how that works. Now, first of all, we're just going to look at this. Cos theta equals negative 0.5. Okay? So I'm going to show you how to do this. Number 1, You look at the sign here. So put a 1 by the sign always, so you know step 1. So step 1 is right here. Where is cos negative? What is it? 2 and 3. That's the first thing. Because there is 2 answers, and you'll see that in a second. The second thing is, so we've done number 1. Number 2, you need to go cos negative 1 of negative 0.5. Because we're trying to find an angle here. This will give you the reference angle all the time. Okay? What do you get as a reference angle? Everybody try it. You're going to be working through these. Make sure you know the right mode to be in. You should be in degree mode. You can always tell by your domain. What are you getting? 60 degrees? Okay. So this equals 60 degrees. Remember, this is my ref angle. Reference angle is always to the x. So we're going to do our 260s here. The third thing is now you find the rotation angles. The first rotation angle, I would go 180 minus 60, which is 120. And the second angle I would do is 180 plus 60, which equals 240. Okay, now that's how you would do this one if it was a written response. If it was a multiple choice, I want you to look at your unit circle. When does cos equal negative a half? $120 and $240. Do you see that? Do you see in your unit circle where right up here and down here? So you see if it was a multiple choice how fast this would be. Yep. You're not getting that? Oh, sorry. Yes. Okay. I should always be doing the absolute value. So I would never put in negative 0.5. So I should have put this. I should have put the absolute value signs of it, which is cos 0.5. So remember, we always want to find the absolute value. So if you put in negative, you will get the 120. But you will never get the 240. Your calculator will never give you the 240. I mean, unless you add 120 plus 60, that's the only way you're going to get 240. But you won't do it by cosine. It'll always give you just the angle less than 180. Yep. Yeah, you can actually find the one answer. Okay. Now, if you go cos 120, you should get the answer negative 0.5. And if you go cos 240, you should get the answer negative 0.5. Okay? Now here's another thing that you need to learn, just one more thing, that sine squared theta can be written, and it is actually always written as sine squared theta. That's the trig way of writing, I want this all squared. So students get really confused when they see it this way, so you have to automatically think of it as sine theta squared equals 0.5. And then what I do is I'm going to square root both sides. And remember, when you square both sides, you have to put the plus minus sign. So sine theta equals plus or minus square root 0.5. Now, now you're actually ready to start the question. So we're going to do our 3 steps. Step 1, decide which quadrants we're in. Where is sine positive and negative? 1, 2, 3, and 4, right? Sine is positive and negative in both. Okay, now reference angle. So reference, you want to sine -1 of 0 square root 0.5. Okay, everybody try it and give me the reference angle. Remember, you're in degree mode. Look at the domain. What do you get? 45 degrees. So, go 45, 45, 45, 45. And then you do your rotation angles. And the rotation angles are done. First one's 45. The second's 180 minus 45, which is 135. The other one is 180 plus 45, 225. And then 360 minus 45, 315. Oh, that's one thing that I should talk about before we go on, so come back, is if you look at this, I'm just going to show you what this is. Square root 0.5, well, that's the same thing as square root 1/2, right? Which is the same thing as square root 1 over square root 2, which is 1 over square root 2, and then multiply by root 2, so you get root 2 over 2. Plus or minus root 2 over 2. Does it make sense now that they're at all those 45s? See, that was, that was disguised. So you wouldn't even recognize it on the unit circle. But if I was doing this on a test and it wasn't a written response, this is how, if you're strategic, I save a lot of time. All I had to do was rationalize the 0.5 square root, and I got root 2 over 2, and I know that where that is in my unit circle, so I write those down. Okay, so it is much quicker if you know that unit circle. Not only that, I verify my answers too. Hey Bennett, you with me here? Now, let's do one where it's cotan x equals root 3. Aren't you glad this isn't the first unit we did? My class might have been a lot smaller, but now it's too late to run, right? You got a pretty good mark, you don't want to mess that up, so it's all strategy. Okay, now, like, how do you even get going on this thing? Well, they give you kind of a hint right here. See, there is no cotan button on your calculator, but there is a tan button. So if you hit tan x equals 1 over root 3. Okay, now we're going to do our 3 steps. First step. Now remember, we're looking here, tan is positive, right? So for step 1, where is tan positive? 1 and 3. Okay, so we can cross those out. Now we go to our second step. Can you find out, using second tan, what my degree is? So now we're on step 2, reference angle. What do you get? 30 degrees. Okay, so you draw 30 there. Draw 30 here. Remember, it's to the x-axis. Okay, so now my rotation angles is 30 degrees and how much? Now this doesn't take long, right? But if you would have realized that 1/3, 1 over root 3, multiply root 3 over root 3, you'll get root 3 over 3. Where is root 3 over 3? At 30 and 210. So just doing that and then knowing my unit circle, you are looking at about 10 seconds per question. And to do it this way only takes a minute, the long way. So you can do it using your unit circle, but come back and do this one the long way the second time through in case you just messed up, right? Now you're thinking, oh, it's the diploma, I'm all going to be messed up and fuzzy and the whole thing. You already drew it. First thing you ever did, draw it, and then it's there. And well, if you take diploma prep, the students said that they just didn't do the unit circle a lot, so they had to do this and stuff. So they knew the answer. They're sitting back going, why are we doing this still? We know the answer, like move on, right? So, it is a good tool. Why, if it was that easy, why isn't everybody getting 100 on it? Because some will not put in that time. Okay, that's how it is. I was telling you in calculus in university, the second calculus has the highest dropout rate of any class in university. And there is about 30 antiderivatives you have to memorize. Actually, probably more than that. It's just a whole sheet. You had to memorize them because they were like, your derivatives of sine or integral of cos, and even just all these things you just had to memorize. It was kind of like the alphabet, right? And then later but why are people dropping out? Because they didn't want to take time to memorize all that stuff. And once you did that, I'm not going to say it was an easy course, but it was not so bad. If you didn't do that, like it's just like you're just lost. You would just go, oh crap, you really need to do your sheet to do this one, eh? Like that's all you would do the whole time. And this is kind of the same way. You'll find this a pretty easy unit if you really know your unit circle. And, I'm going to lose some people. It's summer, whatever reasons, but I hope not. Okay, now this one we're not going to do the whole thing, but how would you do secant x of negative 1.2631? Well, first of all, we don't have a secant button, but we have a cos. So this would be cos x equals 1 over negative 1.2631. Okay, and then you can just go from there and do it identical to we did it above. What's wrong? Oh, I just made this first, okay? I'm just saying these are the same things. Yeah, you want to put in the absolute value of that to find the reference angle. Yeah, never put in a negative for reference angle. The negative will give you one of your angles, though. But it doesn't help you get the other one, unfortunately. So it's no use. It was good to check after you're done. Okay, what about this one? When does cos x equal 0? Anyone know? Think around your unit circle. Where is it 0, 1? Y-axis, which is what? 90 and 270. Now that's how quick you can do these if you know your unit circle. Now, what if you don't know your unit circle? You still can do it because this is positive or negative, right? So you can be in either one. I want you to see how this one works. Now, put in second cos 0, and what do you get? Okay, that means from here, you have to go up 90. And from the other side, you have to come up 90. Okay, and then you've got to come down 90. You've got to come down 90. Now you know your reference angles, so your rotation angles are 90 and 270. If cosecant is undefined, what does that even mean? So that means I can't do it? Who's cosecant's buddy? So I bet you it was sine equals 0 over 1. or just 0, right? Whatever. Because if you were to flip this, it would be cosecant equals 1 over 0, which is undefined. So that's what you would do. When does sine equal 0? Now you should know this. When does sine equal 0? Where? Degrees. I need degrees. 0 and 360. You need to do it in the domain, right? Okay. Now this is just repeating the same stuff, but this is all in radian mode. How do you know you're in radian mode? Because okay, so when does cos x equal negative 0.5? So when does cos x equal negative a half? Okay, think about it. Where would that be? Well, first of all, what quadrants? 2 and 3. Okay, so now go cos theta equals, or sorry, cos negative 1 1/2. What do you get? Now you're in radians, right? Okay, so it's 1.047 dot dot dot. Okay, now what does that mean? Yeah, it's the reference angle. No, what is 1.0? What does it mean with no? It is your reference angle. You're right, but what does that reference angle mean? Like, what is 1 point? How do you graph 1.047? It is, that's radians. That's like 1 radian, right? What is a radian around? 60 degrees, okay? So you're going to get this. I'll do it in a different color. It's this and this. Now, do you remember that's where on our, and this was root 3 over 2, and this was negative root 3 over 2. So there were the two places where it equaled a half. I could have been done there by saying it is, what's the first one? Rotation. Because this is 60. Okay, so it's 2 pi over 3, right? Now, so it's 2 pi over 3, and what's the other one? 4 pi over 3. Okay. When does, let's just go down, do this one. When does sine equal a half? Okay, now you got to be thinking about it. Where is sine positive? One and 2. Now, half. Where is sine equal a half? Is it at 30 or 60? 30, right? And 30 here too, because that's a reflection. So this is not 30. Let's call this pi over 6, right? This is totally doing without your calculator. So what are the two angles? Pi over 6. What do you think the other one is? 5 over 6. Like, the work is very minimal if you know your... Now, even though I have my unit circle memorized, I still actually write it down and go, okay, and really think about it, because you put it in the wrong quadrant, obviously you're done, right? Okay, so for this, we're going to do 1 to 5 A, C, E, dot, 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 and 6 to 11. Got it? Surprise! Woo! Okay, the good news is I am going to give you tomorrow's period to work on this stuff. But lesson 5 is to learn the unit circle. So we've already done the notes for lesson 5, but I had to do it first because lesson 4 is really hard to teach if you don't know your unit circle. So these two do go together well, and we're going to go right to page 534. Okay, so you can see that's what the unit circle looks like. Now the unit circle that I've given to you, I found online a few years ago, and I do like it the best out of any one I've found. It's the least crowded. When they put all the information on the outside, it's very, I mean, put your angles on the inside, it makes sense. But it's important to know what are all the signs on each of them, which one is cos, which is sine, which one's tan, and know the numbers, right? But really know quadrant 1 well and all of your angles, okay? And remember, by knowing them, that's making a unit circle as soon as you get your test. Then it's done. You don't have to remember it anymore. Okay, so we're just going to, like, these are just straightforward. What's sine this? What's sine that? Well, let's go right to P, or sorry, 4, which is P and Q. Okay, there are 2 points on a circle. Now, where would root 2 over 2 negative root 2 over 2 be? Think about the signs. Where is it? What? 3 or 4? Quadrant 4. Now, what angle do you think it is in there? It's a nice 45 right here. Or instead of saying a 45, it's a what? Do this angle in. Okay, so this is 45. What's another way to say that angle? Pi over 4. 45s have, see how the 4, that's how you have to remember it. Now, what about, no, it's just a pi over 4. No, I'm actually not going direct. It is a negative if I was going backwards, yeah, or a negative 45. I'm actually just, that's the angle there. That would be the reference angle. Okay, Q. Where's Q? Quadrant 2. Where is it? Now, it can either be the low 30 or the high 60. Which one? The high 60. So it's up here. Okay, this is Q and this is P. Okay, what is the angle from here to here? That's all I want to know right now. What's this angle? 30 or in radians? Pi over 6. Okay, now what's this angle? 90 or pi over 2. Okay, so how do I, now the question is, okay guys, we've got a lot of talking back there, we need to stop, okay? The question is, what is the angle to go from P to Q? So all we have to do is add these angles up. So if you want it in degrees, the answer in degrees and radians, it was 30 plus 90 plus 45. 165, yeah. Now, if they want it in radians, you could take that and turn it into radians, or you could just go pi over 4 plus pi over 2 plus pi over 6. Okay, now that one, do a common denominator, 12. Okay, I always like doing it underneath. So 4 comes, we've got to multiply by 3, that's 3 pi. This one we have to multiply by 6, that's 6 pi. This one we have to multiply by 2, that's 2 pi. Now 3 plus 6 is 9, plus 2 equals 11 pi over 12. See, it's almost going a full 180, which is pi. So that's why we're close to 12 pi over 12, right? How far are we from doing 180 degrees? 15 degrees. Okay. Without doing your graphing calculator, find the log 2 of cos 7 pi over 4. Okay. What's the log? Hopefully you have your study sheet on that. Okay, let's get through this. So, first of all, what is cos 7 pi over 4? Guys, what's cos 7 pi over 4? Look in your unit circle. Cos 7 pi over 4. Root 2 over 2, right? So this just equals root 2 over 2. So the question is, what's log of 2 root 2 over 2? Because that's what cos 7 pi over 4 is. Now, this is the same thing as log 2 of 2 to the 1 half over 2 to the 1. Now, because those are the same basis, I can subtract exponents, which would go log 2 of 2 to the negative 1 half. Now, what can I do with that negative half? Bring it out front because it's on third level. So negative 1 half. I'm going to write this up here. It goes all around the building. I don't know. I tried. No one's there. Okay, anyway, let's get back to here. Okay, so negative a half log 2 of 2 equals negative a half. Okay. Now, what if you were given a point on the unit circle? It wants the value of theta. Okay? Where would this be? Quadrant what? 3, because it's a negative and a negative. So this is point A right here. So there's point A. How are you supposed to do this next? Now, if you know the answer, you can easily find the angle. Because cos, whatever the angle was, equals this. And sine, whatever the reference angle is, equals this. So how can you find the angle? Inverse, right? So there's two ways you can do it. You can go cos negative 1, 0.6157, or you could go sine inverse, positive, 0.7880. Now, if you put either of those in, you get the answer. Now, oh yeah, this one you want to be in degree mode. They didn't say that. Didn't give us to be in degree mode, or else this one doesn't work. And you get the answer 52 degrees. So this is 52 degrees. So what is the rotation angle? 180 plus 52, which is 132 degrees. 232 degrees. Okay, so then they want you to memorize this chart, memorize, but you don't have to if you know unit circle. Now, just a couple more things and then we're done. The equation of the unit circle. is x squared plus y squared equals r squared. That is for every circle. For our unit circle, r always equals 1. So for the unit circle, make sure you're using this, x squared plus y squared equals 1, or 1 squared, whatever you want to put. A says, would this point lie on the unit circle? Point a half, a half. Well, that stands for x and that stands for y. So all you have to do is try it. 1 half squared plus 1 half squared. Does that equal 1? 1 quarter plus 1 quarter, does that equal 1? So that doesn't equal 1, so it's not on circle. So all you have to do is put it in that formula above if you want to find out. Okay? No, because a half could be the points in between. Okay? I finally made it. Last question. Now, the reason I want to do this is this could be a potential numerical response question. I want you to know how to do it. Now, the equation of a circle with a radius 8. So you know the equation of the circle is x squared plus y squared equals r squared. Now, they give you coordinates, x and y, and they give you the radius of 8, so you can plug those in. Negative 4 squared plus b root 3 squared equals 8 squared. So then we just have 16 plus 3b squared equals 64. Okay, we get rid of the square root, but the b does get squared. Then you want it minus 16 to both sides, right? Doing some algebra here. You get 3b squared equals 48. Then you want to divide by 3. b squared equals 16. Now you're taking the square root of both sides, so make sure you put b equals plus or minus 4. So there's actually two answers that would give that. Okay, so we're doing 2 to 4, A, C, E, G, and 5 to 15. I'll give you the first lesson in 10 seconds here. So, like I said, you will have all of tomorrow's period to work on this. There will not be a quiz tomorrow. There will be 2 on Friday. I will be, yeah. For you guys, I will be. For the morning classes, I won't.